For the recording, here's how to solve any physics problem, any energy problem I give you, this entire module, in short. That should be enough time to write it down. Okay, again, I want to hammer on a couple of ways to screw up and how to avoid them. The meanings. Work causes energy to change. If I start with $5 and somebody gives me $2 more, how much money have I got? $7. If I start with 5 joules of energy and stuff does 2 joules of energy work on me, 2 joules worth of work on me, I end up with 7 joules. Bing, bam, boom, that's it. Bada bing, bada boom. That's energy conservation. If your total amount changes, you can also subtract initial from both sides and say EF minus EI is change in E. How I wrote this last time is change in energy equals work total. That's just an algebraic rearrangement, right? Change in energy equals work done. Your final equals your initial plus work done. Energy conservation. I might have different forms of energy. We'll talk about, well, the last one here. But the total amount is fixed unless somebody adds or subtracts to it. Okay, now, when you're calculating the works, you have to remember what the work equation means and not just multiply numbers because you see them. You have to think about the meaning of adding or subtracting or not energy. And you also have to remember, if you're doing spring force and gravity already, don't do spring force and gravity twice. Don't calculate the work done by gravity if you're already including gravitational potential energy. Don't do calculate the work done. You can't calculate work done by spring if you already have the energy included, energy of the spring included. Thou shalt also remember, the plus and minus and zero sign. If I'm helping something move, if I'm pushing it faster, work is positive of that force. If the directions are aligned, if my force is in the direction of my motion, that's a positive work. I'm adding a positive number to my energy, so my energy gets bigger. If I push someone, don't they go faster? Right? So if I add in positive work, that gets my final kinetic energy bigger. Okay? Work can be negative if I'm braking to a stop. If I'm in a car braking to a stop, the braking force is, God willing, in the opposite direction of the direction of motion. It's pushing backward on me. I am subtracting off. If work of friction is negative, my final is subtracted. I get a smaller number than I started with. And finally, if the force is not helping you, if it's not pushing your back, and it's not pushing you forward and it's not pushing you backwards, that force has zero work, which should make some kind of sense. Gravity does stuff if you're in the air. Gravity isn't doing stuff just walking around, where by stuff I mean helping you or trying to stop you. Okay, so there's a very simple 3-step process for calculating the total energy. And last semester, it took about a week to get through this. And I'd really like not to spend a week. I would like everybody to be able to identify, is something in motion? That shouldn't be hard. I would like you to be able to identify, is there upness? Is something up or down? If height changes, that also shouldn't be hard. And if there's a spring doing something, a spring is either extended or compressed. If a spring is springing, That shouldn't be hard to identify. It's common sense for all of these. If I calculate the three forms of energy that I'm going to give you stuff for and say that that's the total energy, just calculate each number and add them together. If I have a beginning and an end, if I'm not just specifically asking you what's the total energy, if I tell you a beginning time and an end time, you can calculate this twice. Does that sound straightforward? Yeah. Okay, I need to give you a UE equation. Remember UE, spring force, Kx, negative Kx to be precise. Spring force is not constant. Spring force changes as the distance goes. If I stretch a spring a little bit, it's a small force. If I stretch a spring a lot, it's a big force. What's the work equation? Force times distance. But force isn't just a number, it's a thing that changes. You don't know, most of you, well, maybe, you may or may not know how to calculate, how to multiply two things where one of the things is changing. This is an integral. If you do not remember calculus, Merry Christmas, I give you the formula. Spring potential energy is half spring constant times compression or extension squared. Merry Christmas. Thou shalt not get spring constant, little k, confuzzled with kinetic energy, capital K. I don't know of anything that I multiply kinetic energy by. I can't think of any circumstance where I multiply energy by something. I'll divide it later by time. So pro tip, if I just see K added to stuff, I'm talking about energy. If I'm multiplying K by stuff, that must be spring constant. In particular, if I'm multiplying K by X or delta X, I'm talking about force or energy, yeah? Don't get them confused. It should be bleedingly obvious by context. So if you think about what does this represent, you won't get them switched. Okay, let's do an example. I shoot a pop gun up. Pop. The cork goes up, what do they go? 20 centimeters? 0.2 meters? How big are those suckers? They're pretty small. 10 grams? 0.01 kilos? Okay, so I want you to find out the spring constant and the initial speed. Nope, I can't give you the spring constant without the compression. How much do they compress? 5 centimeters? A spring gun, all you got to do is apply this, and you can solve this. This is a 3-time problem. There is before you pull the trigger. There is once the spring has sprung and the cork is going up. And then there's the peak motion. So there are 3 times. We will calculate energy 3 times. Energy 1, energy 2, energy 3. Okay? So again, the question is a spring-powered cork gun. Does everyone know what I'm talking about? The little poppy children's toys. There's a spring, it propels a cork up, goes up. Usually there's a string on it so the kid doesn't lose the cork. And those little toys. A spring-powered, I don't think they're called cork guns, but whatever. Fires a, I estimated there's something like 10 grams. Cork up about 20 centimeters. The initial spring was compressed. Five centimeters? Our goal is going to be defined, as I just said, our goal is going to be to find find the spring constant and find the muzzle velocity, if you will. But I want to check because again, last year there was so much suffering at this point. I want you to simply identify what things aren't zero. Time one. Do you guys remember and know what I mean by time 1, 2, 3? When you pull the trigger is time 1. When the cork is leaving the muzzle is time 2. When the spring is fully sprung, but it hasn't gone up very far, huh? Right? And time 3 is when it reaches its peak position. Do I need to write that down? Okay. At time 1, identify the kinds of energy. At time dose, identify the kinds of energy. And C, at time trace, identify the kinds of energy. Please, if you would, unless you want to lose all your participation points, as I discussed before, write in the following format. Do not write words. Do not write paragraphs. Do not write sentences. I will take off all participation points if you completely ignore me and write that. I want you to write symbols so that I can grade it quickly. Okay? What are the symbols going to be? Your possible choices are K, UG, UE, W, I guess, E. The letters, the symbols that we've been using so far. It's fairly straightforward. Are you guys comfortable with being able to write symbols instead of words? Okay, I guarantee you somebody is going to do this. Ready, set, go. Give this a shot. Simply identify what. Again, no numbers, just symbols representing what kinds there are. Again, all you got to do to find K is it moving? All you got to do to find UG is, has it gone up or down? All you got to do to find UE is there a spring that is compressed or expended? Time 1 is just when you pull the trigger. Time 2 is just as it leaves the barrel, muzzle. Time 3 is when it reaches its apex. Okay, and this is apparently hard. Okay. So we're going to spend a week, or hopefully less. Oh, my sweet baby Jesus, nobody is written in words. Threatening you guys with points actually works. Yep, yummy. The moment you pull the trigger, before it's done anything, the moment it is passing the tip of the gun, and the moment it reaches its highest point. Okay, my dudes, my dudettes. Yes or no question. When the cork is at its lowest point inside the gun, shooting up, question 1, is it moving at the instant I pull the trigger? Google question D, is it moving the instant I pull the trigger? Y or N, please? Yes or no? You can type yes. And we have about 50-50. Let me ask you this. Before I pull the trigger, this is Google question E. Before I pull the trigger, was the pop gun, was the cork moving? Yes or what? No, Y or N, doesn't matter. Before I pull the trigger, is it going up and down? Everyone for this one agrees no. Before I pull the trigger, it is stationary. Okay, tell me this. If you push something, it accelerates. We learned extensively in the first 2 months of class. Something accelerates means it starts moving. Riddle me this, Batman. In one instant, when you pull the trigger, how much velocity do you get? Let me say, acceleration is 1, initial velocity is 0, and time is 0. What's your final velocity? Google question F. If I accelerate it, I don't know, 1 meter per second squared for 0 seconds long, how much velocity do I pick up? Let's review our equations. Let's review the equation for acceleration. Acceleration times time step equals my change in velocity. You could divide both sides by time if you want. You could solve for final velocity if you want. I have told you that acceleration is 1, time is 0, and initial velocity is 0. Solve this algebraic equation for final velocity. That is a bigly hint for question F. Okay, well, I'm just going to say if I multiply a number by 0, I get 0. 1 times 0 is 0. In an instant, acceleration does not accumulate motion. In one instant, in a time of epsilon duration, I do not change my velocity. My final velocity must still be 0. You are, at the instant you pull the trigger, not moving. There's been no time to have accelerated. What form of energy did I just deduce you don't have? Google question G. What do you know you don't start with? Letter only, please. What form of energy did I just deduce you don't have? Google question H. What did we just deduce about the velocity? What is the velocity the instant you pull the gun? Tell me a number. 1 meter per second squared for 0 seconds. What's my final velocity? Again, I'll remind you, I will help out that 0 times 1 is not 1. 0 plus 1 is 1. 0 times 1, if I have 0 ones, I have 0 change in velocity. The correct answer was 0 meters per second. And I'm going to move on. If I am not moving, what is motion energy? What term did we talk about for motion energy? What is the energy of movement? It is kinetic. Okay? The correct answer for Google question G is you don't have kinetic K. Again, I refer you to the previous slide that you maybe have written down or looked at, considered briefly. Come on, if I'm everything sucks. I refer you to the previous slide. For God's sake, why can't I change slides? I refer you to the previous thing. Is it moving? Then kinetic. Kinetic goes back to the Greek word kina, kinema, cinema, the moving pictures. Movies is the origin of the kina prefix, motion. If you have kinetic energy, you are moving. We have just deduced that there is no motion, therefore there is no kinetic energy. Okay, so at time 1, there is no kinetic energy. Again, I will reflect on this. Which direction does the cork go? Up. At the beginning of the problem, how high up am I? Am I starting at the bottom? Am I starting at the middle? Or am I starting at the top of the motion? I hope you conclude that at the beginning, when the what's it is in the barrel, I am low, I am down, I am not yet up. Google question I, what form of energy did I just argue also does not exist? What other form of energy must be 0? Google form I, what did I just argue through must be 0 if you have not yet gone up at all? Again, I'm asking what I just said in the last 2 minutes. Not what I said 4 minutes ago, what I said 2 minutes ago. I'm helping you reason through steps. This is step dose of reasoning. If you have not gone up, what do you not have? The correct answer is gravitational energy, UG. Gravitational potential energy happens when you are up. If you are not up, you do not have UG. Okay? Yeah? 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 Great. Do you have any form of energy the instant you pull the trigger? Yes, Yami, you do. You do have energy. Google question J, can you tell me? No, she already said. Spoilers. Okay. There is a compressed spring in the cork gun, right? You've all seen these, right? Or at least seen a cartoon picture of them? Okay. So if there's a compressed spring, I refer you to your previous, no, yeah, I mean, it's fine. I refer you to the previous slide that says if there's a spring, compressed or extended or whatever, if a spring is doing its thing, then there is UE. So let's see if you were listening. Google question J. What is the form of the total energy at the beginning, at the instant you pull the trigger? What should you calculate in order to find total energy here? The correct answer, no, I just want the letter for now. Identifying is something up, Is something moving? Is a spring springified? That's all I'm asking to identify now. We'll type in formulas in a minute. Okay. So as we just argued, it is not moving yet, so there's no kinetic energy. There is a springified, so there is spring energy, UE. It is not yet gone up at all, so there is no gravitational energy. The correct answer was UE, and only UE. Okay, so we have now reasoned through the correct answer for the initial time one form of energy. It's UE, it's only UE. It's always been UE, but here's how to think about it. Question 2, the spring has extended to its full extent. The springs don't come out of the gun, right? The cork comes out of the gun, the spring doesn't come out. So at the instant when the spring has reached its full extension, reached its equilibrium, the spring is transferred its energy into the cork. The cork is moving past the barrel, the tip of the barrel. Tip of the barrel? That one says? The muzzle. It has gone up a bit. Let's try again. At that time 2, as I said before, Google question K, what form or forms of energy do we have? It has moved up 5 centimeters. It is moving at some unknown speed. Spring is no longer stretched. Let me repeat my words here. Think, visualize what's going on. Is the spring stretched when the cork is coming out of the gun? No. As I described before, the spring does not pop out as well unless the cork unbreaks. The spring is not stretched. So what kind of energy isn't there? There is no UE. There is no elastic potential energy. The spring has released all of its energy once the cork is leaving the gun. Is it moving? Most people said yes, there's kinetic energy when it is moving. And the last is, has it gone up at all? Is it in the same height? Yes. So what form of energy should you include in your answer? UG, exactly. The correct answer was kinetic and K and UG. Third instant, visualize, picture this, imagine this. We are at the peak position. The cork has gone up as high as it's going to get. Before it falls back down, what form or forms of energy do we have now? Google question L. You may refer to the previous notes on how to discuss, how to think about the other forms of energy. How to think about any of the energies. Catherine, at the instant that the cork is reached its highest apex peak of motion at the top of its, I guess, 25 centimeter ultimately, rise, what form or forms of energy do we have? Google question M. In this problem, what is the velocity at the peak height? Google question M. How fast are you moving when you were at your peak position? Again, Google question M. What is your velocity at your peak position? And someone has been typing words. Someone gets a 0. What is your velocity when you have reached your highest position? Okay, most people believe that it is not moving when it is at its highest point, and that is correct. At your highest point of motion, at that instant, you are not going up and you are not going down. You had a positive velocity, you don't anymore. You're about to have a negative velocity, you don't yet. What can you conclude is 0 based on this? Google question N. What can you conclude equals 0 based on this reasoning? What form of energy must be 0 based on what I was just saying? Okay, based on the reasoning that you are not moving, the one and only term that involves motion is kinetic energy. You can deduce if you are at rest, your kinetic energy is 0. Again, I refer you to my previous slide where I said, is it moving? Kinetic. If you are not moving, no kinetic. At the peak position, it is true that you do have gravitational potential energy. Are you not up at your highest point? It is not true that you say UG is 0. That is a lie. It is true that the spring is not compressed or extended. Spring potential energy, UE, is 0. But what I asked is, what can you conclude from what I just said? I was not talking about springs. That is not a logical argument to say velocity is 0, therefore the spring is not compressed. Correct answer to what we were just talking about is K. K alone, just K. You now know, you may write this down if you wish, you now know, although hopefully you can reason about it, that you start with spring energy, UE. As it's leaving the muzzle, you've got both kinetic and a little bit of potential energy. Gravitational potential energy. The spring is, and at the peak of your motion, you have only positional, gravitational potential energy. I tell you, I claim to you that all of these totals are equal at each instant. Time 1, the value of spring energy is equal to, at time 2, the total of gravitational plus kinetic energy is equal to also, at time 3, just the gravitational energy. You must now tell me, plug in your numbers and solve for what you don't know. Google question, find the height, maximum height. I already told you the height. Find the what did I ask? I gave you find the initial spring constant. There you go. That's the first step that I would say. Find the spring constant. K, not to be confused with K. And Google question P, plug in. P stands for plug in, and find the muzzle velocity. Okay. So, give me a number. You can include units as well. I do not want a paragraph. I do not want words. What are the units of K, by the way? Newtons per meter. I wouldn't take away points if you don't include the unit, but frankly, I think it's helpful. If you can do this, you can do anything I give you. Because it's all the same problem, just with different words. Again, based on what I've given you, you can find the spring constant and you can find the muzzle speed. Do that. Plug E in, solve a. I will remind you, by the way, that we assumed that the initial height was 0. Hint, 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 hint. Thou shalt think carefully about the final height of the object, by the way. Hint, hint, hint. Where am I after I go up initially by 5 centimeters and then go up by another 20 centimeters? How high up am I? Am I 20 centimeters up? No, I am not. First I went 5, then I went 20. Where am I? If you walk 5 miles and then you walk 20 more miles in a straight line, how far are you? Hint, hint, hint. Oh, I guess my words could be interpreted that way. I should say above the gun. My mental picture may be different from yours. The 0.2 meters is how high up above the gun it goes, not the total distance. I will remind you also that the units for spring constant are not joules, newtons per meter. And I'm going to call this time. If you know that the initial energy, the energy at time 1, is only spring energy, you can write down that equation. If you know that that energy is the same as a later energy, which is both potential and kinetic, and I'm going to write this as V2 because it's the velocity at time 2, even though it's the only non-zero one. And I know that the third instant is only, this is silly, height at time 2, height at time 3. If I know the energy is purely gravitational, as we reasoned through at the third instant, I write mgh3. What terms did I tell you about? What do you know? What can you plug in and solve for? Well, pro tip, if I'm asking about K, you can't finish E1. And if I'm asking for V, you can't finish E3. The only term I think you can finish and evaluate to get a number is energy 3. What is that? 0.01 times, I'm going to use more precision here, 9.8 times how high did we go? 25 centimeters? You may have interpreted the 20 centimeters as the total height. That's why I went back and said above the gun. I go 0.2 meters, I go 0.05 meters, I go another 0.2 meters. My total is 0.1, 9.8, 0.25. 25 millijoules. Okay. I can use this to solve either E1 or E2 directly. I was asked for spring constant first, so I'm going to do that. I can plug into the equation 1/2 times unknown times what is the compression, the meaning of delta x1? Okay, so I could say if this is the initial energy and I don't know K, but I do know it's equal to that final energy, I can pluggy any and solve for K as 19.6. Alex, what did I say? That was a test and you passed. Thank you. Which I typed into the calculator, not on the board. Okay. Okay. So how did I get K equals 19.6? I imposed the condition that the two things are equal, and I solved for K. That's all there is to it. At the second time, I can plug in and I could say this is the total amount of energy. I don't have to recalculate him. I'm just going to plug into this expression and say that they're equal. What is H2, by the way? How high do you get when you hit the muzzle? I hope you agree that it's 5 centimeters because I told you that the initial spring was compressed by 5 centimeters, 0.05 meters. Plugga plugga, chugga chugga. V2 is very close to 2. Okay, so the math is killing a lot of people. Let's turn to your neighbor and please help each other with the algebra here or whatever. Talk to each other. I would like a question or 10 about the process, about the physics, about the anything you want related to this, wherever you're struggling. Turn to each other and discuss. Put a question in queue. Tell me where you're struggling. If you tell me I'm not struggling or no question, I will take away your participation points. Again, if you have nothing that you want to ask, don't put anything. You don't need to put anything if you don't have a question. But if you have a question, please put that in Google Form Q. And then I will answer them. .29, where's .29? I don't see any .29s. .29, is there a .29 on the board? No, there's a .25 here. Does that look like a 9? I have hidden the, what have I hidden? I have hidden the people who responded. Oh, for dog's sake, where did I freaking put the freaking, there it is. I've hidden the names, but here are the questions. Please turn to your neighbor and answer these questions for each other. I'm going to scroll down in a little bit, so hop to it. Physics is not just about, I know how to get the right answer, but also about why the wrong answers are wrong or where the stuff comes from. So please talk to each other real fast and be able to explain to each other. Then I'll give my explanation. You can get it from how far something travels. Gravity, obviously, and then how heavy or not how heavy, the mass of whichever of the object of E1 is basically the spring energy. So you can't really get the spring energy without knowing what K is. And K is for E2, so you kind of, yeah, like you go 3, 2, 1. Okay, I encourage you to learn from the mistakes of others. In life in general, you don't have time to make all the mistakes yourself. So please do not turn off your ears when somebody who's not you has the question. Person 1 asked the first question, I thought the calculation was E1, why is it E3? If A equals B equals C, then A equals C. I know something about time 3. I have all the numbers to calculate in time 3. I want to know something in time 1. I don't need to calculate time 2 as well. If 3 things are equal, they're equal to each other. So I can say E1 equals E3, I could say E1 equals E2, I could say E2 equals E3, whatever makes my life the simplest. Question dos, where the 0.29 come from? Messy handwriting, sorry. You can tell, you can deduce what that means because I wrote mgh equals the mass, 0.01 times 9.8, which I hope you know is G, times 0.25. What is 0.25? It's H. Question 3, is it always time 1 equals time 2 equals time 3? No, absolutely not. What did I say at the beginning? Final energy equals initial energy plus work that's not gravity or springs. In this problem, there was only gravity and springs, so I could say all the energies are equal. Initial equals final equals later final. Yeah? In general, you would have to add work done, which may be positive, negative, or 0. Did I multiply or divide kx when finding O? When I found the spring constant k, I have something times k equals something. Both somethings are numbers. If I have ax equals b, and I want to get x, I look at how are a and x attached. They're attached with multiplication. Basic idea of algebra is you do the opposite operation. A times x is a multiplication, so I divide by a. Correct answer is I did not divide kx, I divided half x squared. There is no kx in this. We're not talking forces. Next question. The spring energy, gravitational energy, and kinetic energy are all equal? Absolutely not. The initial spring energy equals the middle kinetic plus potential energy. You've got some potential energy. There are two different places where you are up. In the middle and in the end, you are up. So you can't just say 3 things are equal. They are not equal. Total energy is equal to total energy is equal to total energy. And thou shalt think carefully about what total energy is made up of. Next question, why did I use 0.05 for H2? I did not use 0.05 for H2. I used 0.05 for, yes, I did use 0.05 for H2 because I said you start at the bottom of a gun. Well, hopefully that's where bullets, corks start. And then when you fire the gun, it goes up. When it's at the tip of the muzzle, and I told you the length of the muzzle, how far is it gone? That's its height. If you go up from your initial point to the tip of the gun, the height is equal to the length of the gun. If that's confusing, I encourage you to draw a picture, draw a little sketch, and it might help. X1, as I described, X1 is how much the spring is compressed. Again, you got a pop gun and you push it down into the barrel of the gun. The amount of change of length of the spring is equal to the length of the what do you call that? The action of the gun? I don't know gun terms. Why didn't we only use energy 1 for question O? Because you didn't know energy 1 until we solved for it. Well, until we solved for energy 3. Where did MGH come from? I refer you to the previous lecture. We deduced that. Knowing which equations to use for the problem or knowing what exactly to use. There is only one equation to use. You need to know what kinetic potential and spring potential and gravitational potential are. You need to know what work is. But there is only one equation that you apply for every damn problem in this module. Initial energy equals final energy plus other works, all other works. There are no other works, so we just said initial equals final. Okay, so having trouble with solving for K. We'll do that in a second. Can we do an example problem with work for the go-around? Wait, hold on. With all work for the first go-around and ask us a similar question. Oh, you want me to demonstrate plugging in numbers first? Okay, I'm sorry, but absolutely, positively not. I am trying to teach you to think, not monkey copy, monkey see, monkey do. And if you are copying a pattern that, as proven educational psychology, there have been multiple tests of this, the more you are following a rote pattern, the less your brain is engaging. I'm sorry, but that is a bad educational practice. I will not have you do a similar problem to me 5 times. That's elementary school, my dudes. And if you're above your elementary school level teachers have been using that, then I say shame on them. Okay, I'm going to solve the 1/2 kx squared again. Are these always the equations for k, ue, and ug? Yes, absolutely. K is defined as half mv squared, so on and so forth. Where did the 0.25 come from? Answered that. When do you add the heights? Answered that. I said the energies are equal to each other. Yes, they are equal to each other. They are all equal to each other. Use the central one and only equation in this section. Initial energy equals final energy plus other total work. I should say total other work. There is no other force other than the things given, so initial equals final at each time. Why couldn't you use 0.2 meters for the height? Because that's not how high it is above where it started. It went up 5 centimeters, then it went up 20 centimeters. It didn't go up 20 centimeters, it went up 25 centimeters. Okay. So let's switch back to here. I need to go to share. Life is suffering. Share, damn it. Start broadcast. Okay, thank God. Okay, so the big question was solving for K. I have 1/2 times K times 0.05 squared equals 0.0245. I claim that the big idea of algebra is if you've got operations on something you want, undo those operations one at a time by reversing them. If I'm multiplying by 1/2, I can get rid of 1/2. I could divide by 1/2, or I could multiply by 2. If I multiply both sides by 2, I get this. The next line is, what have I got attached to K? I got 0.05 squared. If I want to get rid of 0.05 squared, I've got to do the opposite operation. How is K attached? It is multiplying. If you have K, x squared, that's an implicit multiplication. xy means x times y. So I would divide both sides. Oh, that's what happened. There, that's how to solve this equation. Follow-up questions for any of those explanations? Please reflect on what you do. Again, it's the same damn process for every single thing. You have to reflect on what form of energy do you have at the beginning. Is it up? Is there a spring compressed? Is it moving? When you can answer that, you can write down an expression for total energy. If there are any other forces, and usually the maximum I give is one other force, If there are any other forces, calculate its work. Here's the one and only central equation that you will always use pretty much every damn time, unless I'm just prompting you for an individual part. How much do you start with, plus how much do you change by, equals how much you end with. Another example. How much time do you have? 3 to 4:15. You have enough time for one. Half pipe looks like this, by the way. And no, you don't need circular motion here. What are we on? What are we on? What letter are we on? Probably Z, right? R, R, exercise R. Many correct answers so far. You got one more minute. Okay. The one and only mistake that I see is the only one and only mistake that is popular here is not thinking carefully about what radius means. I claim that this is 3.0 meters. If that's 3.0 meters, do I go up by 6 meters? Where do I start? Here. Where do I end? Up here. Well, that's along an arc length, but fortunately, gravity only cares about vertical distances. If I go straight up, oh my sweet baby Newton, look, if I go straight up, I'm at the center of the circle. How far have I gone? 3 meters. So I claim there are no other forces that do work here. So I can just write down my initial forms of energy, which are what? There's only one. I'm not up and there's no spring anywhere in the problem. What's my final form of energy? If I'm just barely making it, my only form of energy at the end is gravitational potential. I plug in. Oh, this is convenient. Look, I don't have to use 55 twice. Cancels out. I want to find the speed. So first, I get rid of the multiplication, undo operations, reverse order of operation. And finally get velocity. I undo a square by square rooting, root 2gh. Final answer, 7.5, 7.7. You have enough time. Google question S. Tell me what's hard about this. If you don't have something that's a challenge, you can ignore this. Tell me where this is a struggle, though. Again, do not tell me I'm fine. But you may ask a question, and I will answer them as fast as I see them. Can I re-explain how kinetic energy and gravitational potential energy are equal? Because that's what the equation says, my dudes. Final energy equals initial energy plus total other external work. There is no other force that is acting on this that is doing any work. Normal force is at right angles to the displacement. Normal force does not do work. The ground on the body, the ground on the skateboard doesn't move you up. So initial equals final, and those are the only two forms that we got. Remembering that half mv squared equation, well, yeah, no, hold on, Cowboy. The challenge was remembering that half mv squared equals mgh. No, don't remember that. Don't remember that. Remember that energy final equals energy initial plus work. How much does my energy change by the amount of work done? Find the initial energy. It is not always true that initial is half mv squared. Find the final energy. It is not always true that it's mgh. You have to apply to each individual problem as fits it. Ki, what does that stand for? Kinetic initial. Subscript I always means initial for me. Na, oh, look, someone wants to get a 0. Is mass ever considered in a problem like this? Yes, half mv squared equals mgh. But oh, look, the first algebraic step is I can cancel. Why don't we consider the full distance along the ramp? Because it's mgh, not mg arc length. Knowing what equation to use, there's only one. There's only one equation to use. Final equals initial plus work. What is UGF? U always stands for potential. G stands for gravitational. F stands for final. Final gravitational potential energy. And we are now out of time. The quiz and the homework are up and they will not be changed. Give it your good old college try. I'll blast it.